All right, so 3.1. Measure center of center. So a measure of center really is, I'm just going to go through the definition. So a measure of center is a value at the center of the middle of the data. So it's extremely vague. So that's why when we say measures of center, we have multiple measures of center. So the very first one, which the reason why I bring it up first is because it's the one that we use more often than not to measure center. The mean, or the arithmetic mean, is a set of data, is the measure of the center found by adding all the values and dividing by the total number of values. Now, what's important about the mean is the sample mean is drawn from the same population, tend to vary less than other measures of sample center. So what that means, what that tends to mean is, say if I want average age of the student population, what I can do is I can take a sample of 30. Actually, I can take multiple samples of 30. So if I take multiple samples of 30 and I determine their mean age, what we're going to know is from all those samples, the mean age is going to be pretty close over and over and over again. Now, the mean of data of the data set uses every single data value. That's actually why that's the case. But there's a disadvantage to using every single data value. Say if one sample, I have an older person here, because we know that average age of college students tend to be somewhere in their 20s. But every now and then, you have older students come back, people in their 60s, 70s, and even 80s. So if I have an older student come back, that one person could actually drag that mean all the way into the 30s when it's not really representative of the data. So because you're adding all the numbers up and dividing by how many there are, it's not very resistant to a larger number, to an outlier. So kind of a quick example of this is if I want to find the mean. So let's say I take a sample. I'm not going to use a very big sample. Let's say sample student age. So sample of student age. So from my random sample off the top of my head, so this is not random at all. I'm just making it up. But this is how we're going to find the mean. So sample of student gives the data below. Determine the mean. So below, so sample A, what I get is I get somebody that's 17, and then the next person's going to be 24. The next one's going to be, say, 20. Next we're going to have an 18, probably another 18, and probably another 18, and then we'll say one more. Let's say a 27. So if I want to find the mean, well, the mean is found by, they say you sum up all the x values and you divide by how many there are. So that little notation means add up all these values. That's what this notation right means. That means add everything up. Add what up? Well, add those things up. So these are your x's. So remember that, I should say, in years. Because whenever we find this data, we need to make sure not to forget units. So what we're going to do is we're going to add them up. 17 plus 24 plus 20 plus 18 plus 18 plus 18 plus 27. And divide by how many there are. 1, 2, 3, 4, 5, 6, 7. So divide by 7. So what we have here is 17 plus 24 plus 20 plus 18 plus 18 plus 18 plus 27. And then just kind of go back to make sure I didn't mess that up. 3 18s. 20, 24, 7. So what I get is I get 142 on the top. 142 divided by 7. So to divide that by 7, what I get is I get 20.28571 ... So we'll talk about rounding here as well. So when we round one decimal past the given data. The given data were integer values of years. So what we're going to do is we're going to go one decimal beyond that. So we're going to go one more to the right. So that means we're going to go to this number right here. Because remember, the data was given in integer values, which was like this 20, but we're going to go one more beyond that. So in order to round this number, we look at the number after it. This 8 is going to make that 2 turn into a 3. If this 8 was a 4 or less, the 2 would just stay a 2. So the 8 is going to bring this number up to a 3. So this is going to be 20.3, and don't forget units, years. You could just say years if you want to as well. So this is 20.3 years. What happens if I put, say I put somebody that's 87 there? It can happen. It's happened a lot. So mean. So let's say I have a new one of, so instead of doing that, let's just say letter B. So let's do the exact same numbers. And then let's say I have a 87-year-old. So I've had them. So that happens more often than you think. A lot of people want to come back to college, and I'm happy for it. So when I add all those numbers up, that 17 plus 24 plus 20 plus 18 plus 18 plus 18 plus 27 plus 87. Now I'm going to divide by 8 because there's another value there, right? So I'm going to cheat a little bit. I already know that the first numbers add to 142, so now I'm going to add 87 to that. So this is going to be 229 divided by 8. 229 divided by 8. So what you're going to notice is that one person jumped up that sample by darn near almost 9 years. And just one person changed it almost by a decade. So this is equal to, I have 28.625. Now remember, again, when we round one decimal past the given data, the data was an integer value, so the data was given like to 28. So that means I have to round this number. Now what this 2 says, since that 2 is less than 4, that means the 6 is going to stay a 6. So 28.6 years old. Don't forget your units. Don't forget to round correctly. So that's why we say that the mean is not resistant to outliers. So this person is much older than the other one, so it would be an outlier compared to the other data points. That's why it's changed so much. Median. The median, essentially, by definition, is the middle number. So if you look at the definition, it says the median of the data set is the measure of center that is the middle of data when the original values are arranged in an order of increasing or decreasing magnitude. So we'll just do it in increasing magnitude. So let's do the exact same data. I'm going to find the median. I'm going to do it on both. So example, use the ages of students to find the median. So in sample A, I have 17, 24, 20, 18, 18, 18, 27. And then B, we're going to put the numbers in here too, because I want to talk about the properties and why we actually use median for wealth. Okay, so when I want to find the median, what I have to do is it says first I have to arrange them in ascending or descending order. So let's just do ascending. So the smallest number is 17. No, the next one is 18. The next one is 18. The next one is 18. The next one would be 20. Next I have 24, and then next I have 27. Let's make sure I have the same numbers. 1, 2, 3, 4, 5, 6, 7. So I have the same amount of numbers. So I didn't mess that up. So the median is going to be the middle number. So 1, 2, 3, 4, 5, 6, 7. So since there's 7 numbers, this is going to be the median number, right? So the median number, the median is going to be the middle number of the set. So that's the middle number of the set. 3 above, 3 below is going to be equal to 18. Don't forget the units. Now, if I want to find the median here, again, I got to arrange them in ascending order. So 17, 18, 18, 18, 24, no, 20, 24, 27, 87. Let's make sure. 1, 2, 3, 4, 5, 6, 8. Okay, good, we're good. Now, if I want to find the median number, well, notice how this is an even number. So what I have is I have 4 below, I have 4 above. So that means these numbers right here are going to be the median, these middle 2 numbers here. So in order to find the median here, you take the mean of the middle numbers. So I'm going to take 18 plus 20 and divide it by 2. You're going to see I'm going to get 19 years. Now what's nice about the median is resistant to outliers. It's kind of cool, as you can tell that notice how the median in both cases, like the median here was 20.3, but the median here was 28.6, not very resistant to outliers. The median here is 18, which is still pretty close to that 20 that we had before, so it's still a pretty good measure of center. But even with the outlier, this was still 19. It didn't change by much, so really this is very resistant. Now, we use median. If you ever look at data for income, it's always median income. The reason why we use median income is because remember that income is extremely skewed right. We have people that make just a ridiculous amount of money, and we cannot put them into our average, because if we're going to add up how much money everybody makes and divide by how many people there are, well, then you kind of see this wealth gap that we have. That if you divide by how much money there is divided by how many people there are, everybody should be making millions of dollars. So it's so that's why, since there's such a huge gap in the very, 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 very rich, and then the rest of us, we use median instead. So since it's so resistant to these outliers here, if we use the median, we'll actually get a number that's more representative of our population. Mode. The mode is a mode of a data set is the values that occur with the most frequency greater than 1. So it's the ones that happen the most, but it has to be greater than 1. So if you look at our previous data sets, the mode of this is 18 because 18 happens 3 times. The mode of this is also 18 because 18 happens 3 times. It is possible to have more than one mode. So example, determine the mode. Of, let's just say I have 17, 17, 18, 18, 18, 20, 24, 27. So in this particular case, my mode is still just 18 because 18 happens the most times. But let's say one of those 18-year-olds are gone, or I get another 17-year-old, so 17, so this should be years. I'm still talking about age 17, 17, 17, 18, 18, 18, 20, 24, 27. So now this has 2 modes because this happens 3 times, this happens 3 times. Or even if you got rid of these 2, those are still, 17 and 18 are still the modes because 17 happens twice, 18 happens twice. So the modes would equal 17 years and 18 years. So it happens to have 2 modes. Mid-range. Definition of mid-range is the mid-range is the data set of measure wow. The mid-range of a data set is the measure of center that is the value midway between the minimum and the maximum, the max and the minimum of the original set. So the way we find the mid-range is you take your maximum value, you add your minimum value, and you divide by 2. So what you're doing is you're averaging the biggest and smallest number. So C, let's find the mid-range of the above problem B. So if I want to find the mid-range, what I do is I just average the min and the max. So the mid-range is supposed to be an R. The mid-range is equal to, you take your maximum number, you add your minimum number, and you divide by 2. So 27 plus 17 divided by 2 gives us 22 years. Now I don't have to, in these particular cases I haven't had to round. It's just what happens in these particular 2 cases. Because I'd always round 1 decimal past the given data, and since these are integer values, you'd go 1 more beyond that. And since these things are all coming out to be integers, I don't have to round. Now the mid-range is not resistant, so remember if I put a big number in there, here, it's going to change this number quite a bit. So if you put an 87 here, this number is changing by a lot. So the mid-range is probably the worst when it comes to resilience or resistance. A weighted mean. So to find a weighted mean, or the mean of a frequency distribution, which is the same thing, so determine the mean of a frequency distribution. So to determine the mean of a frequency distribution, it says x bar is equal to the sum of f times x all over the sum of x. Now let's pull out our previous frequency distribution and we're going to find the mean of this. So example, determine the mean of the frequency distribution. So I have age of actor and then frequency. We had 20 through 29, 30 through 39, 40 through 49, 50 through 59, 60 through 69, and 70 through 79. And then the frequencies were 1, 28, 36, 15, 6, and 1. Now they should put a little disclaimer in here that in this case, x is the midpoint of the class. So I'm going to make sure to put that stipulation in there. So when we see these x values here, these represent the midpoints of the classes. So let's kind of give an idea of what we mean by the mean. Remember what the mean is. The mean is you add up all the numbers and divide by how many there are, right? So what I know is that there is one person that's in the 20 through 29 range. So one person in their 20s. So do you know what that number is? Do you know exactly the age of that person? Well, not without the original data, not without the data that we used to create this thing. So what would be a good guess? What would be our best guess here? Well, the best guess is just take the average of those numbers. So just take the midpoint. So, the average of those numbers, 20 plus 29 divided by 2. So I'm just going to put the midpoint here. Midpoint of the class. So the average of that class is 24.5. The average of that class would be 34.5. The average of these numbers is going to be 44.5, 54.5, 64.5, 74.5. So remember when we do the mean, the way the mean is done, x bar is really the sum of all the x's divided by n. It's all the sum of all the x's divided by n. So I'm going to show you that that's what we get here. So remember I have to add, there's one of these people, right? So this is my best guess for that person. So there's one 24.5. The question is how many 34.5s are there? Because remember, I don't know their numbers, so how many of these are there? Well, there's 28 of those, so plus 34.5, plus 34.5, plus 34.5. I'm not writing 28 of them, right? But I know that there are 28 of these, right? Plus, you're going to have that 44.5 plus, and there are going to be 36 of those, plus, and so on, right? And then I'm going to have to divide by how many there are. Well, how many there are is this number down here. There's one of these, 28 of these, 36 of these. So there's 1 plus 28 plus 36 plus 15 plus 6 plus 1. So let's show you the math now. So what I know is there is 1 24.5. There is 28 34.5s. There is 36 44.5s. There is 15 44.5s. There is 6 54.5. Let's make sure I didn't screw that up. This should be 54.5. There is 6 64.5s plus 1 74.5. Notice what that numerator is? This is f, and this is x. And that's the sum of all of them. So that is the sum of f times x. F and x, f and x, f and x. So this is the sum of f times x. It's this numerator up here, the sum of f times x. All over, well, this is the sum, this is all the x numbers, right? So 1 plus 28 plus 36 plus 15 plus 6 plus 1. That's the sum of all f. And you can see that's why we get this formula up here. Which really is, remember, you're just calculating the mean. It's nothing more than x bar. But unfortunately, you don't know the original value, so you have to use the midpoints as the best guess. So when I calculate this thing, I'm just going to pop it in my calculator, let it go. Actually, let's take a look. You should have an idea where that number is going to be. When you look at this frequency distribution, you notice how you get a lot of 30s, a lot of 40s, and a lot of 50s, right? But there are more 30s and 40s than 50s, right? So what I'm kind of expecting is I'm expecting low 40s. because there's a lot of 40s, there's a lot of 30s, but there's more 40s than 30s. But the 30s, there's enough of this to make this not 49, right? It's probably going to be like 41 or 42. And you can kind of see, if you looked at this bell-shaped curve, you can see that the bell shape would be something like this. If you're going to look at the curve, look at it this way. That mean should be somewhere around there. So that mean should be somewhere in the, I'm expecting low 40s. Let's see what happens. So 1 times 24.5 plus 28 times 34.5 plus 36 times 44.5 plus 15 times 54.5. If you guys can see this. Plus 6 times 64.5 plus 1 times 74.5. I know I don't need parentheses for that, but just to show you that's the exact same formula. So enter. So I get 3871.5. If I made a mistake, I'll know when I get a funny looking answer. All divided by the sum of f. So I'm at 1 plus 28 plus 36 plus 15 plus 6 plus 1 all over 87. So when I take this number divided by that number, what I get is I get 44.5, which is honestly pretty close to what I expected. It's funny, it's the midpoint. But it's kind of what we expected. I expected it to be somewhere in the 30s and the 40s. Or somewhere in the 40s. So this is 44.5 years old. Now it's years old because remember this again was the age of the best actor. So the units are not always years. Sometimes it's money, sometimes it's time, and other things in time. Sometimes it's height. Okay, so and that's it for that section.